The Pythagorean theorem tells us that a squared plus b squared equals c squared, or in other words, the area of the squares off of the legs equals the area of the square off of the hypotenuse. Well, let's use that to solve a problem. A ladder is based 5 feet from the building and needs to reach a window 12 feet high. How long does the ladder need to be? Well, we need to know what our legs are and what our hypotenuse is. Well, it tells us a ladder is based 5 feet from the building. So that would be this part here. This would be our 5 feet. So that's one of our legs. That's going to be A, so we're going to fill that in there. Then it tells us it needs to reach a window 12 feet high. So that would be this part of the shape here. This would be 12, so that would be our other leg. So we're going to fill it into our equation there. Then it tells us that we're looking for how long the ladder needs to be. Well, the ladder is going to be our hypotenuse. So that's going to be C. That's the part we're looking for. Now let's use our information to solve. 5 squared is worth 25, 12 squared is worth 144, and combined, those are going to be worth c squared. 25 plus 144 is 169, so 169 is c squared. But we're not done yet. 169 is the area of the square off the hypotenuse, not the hypotenuse. So to find the hypotenuse, or c, we still need to take the square root of each side. When we take the square root of 169, that is exactly 13 feet, so that tells us that our ladder needs to be at least 13 feet tall. It doesn't always work out that we have perfect squares. Let's take a look at a problem where we're going to have to do some rounding. At a baseball diamond, it's 90 feet between each of the bases. The first baseman needs to make a throw across the diamond to the third base. How far does he need to throw the ball? Well, he's going to have to throw the ball from first base to third base. So home plate makes our right angle, so that means we're looking for our hypotenuse, C. It told us the distance between each of the bases is 90 feet. So our one leg A is going to be 90 feet from home plate to first base, and then from third base to home plate, that is also going to be 90 feet for B. So now we can solve. 90 squared is going to be 8,100, so 8,100 plus another 8,100 is going to give us c squared. Add those two together and we have 16,200 is c squared. So to find the value of our hypotenuse, we're going to have to take the square root of both of those sides. Well, this isn't a perfect square. If we punch that into a calculator to figure that out, we get 127.2792, yada, yada, yada. So we're going to go ahead and round that off to the nearest 10. That 7 tells the 2 to bump up to a 3, so we're going to round that off to 127 3/10 feet for our hypotenuse. So the distance that you're going to have to throw from first base to third base is about 127 3/10 feet. We can also use the Pythagorean theorem to find a missing leg. Here we can see that it's A that we're looking for, so we're going to fill that into our equation. So that means B must be 9, so we can fill that into our Pythagorean theorem. That leaves C, the edge across from the hypotenuse, to be 11, and that to go into our equation. Now we can start evaluating. A squared is what we're looking for, 9 squared is 81, 11 squared is 121. So now we can subtract 81 from both sides, and when we do, that tells us that A squared is going to be worth 40. To get down to just A, we need to take the square root of both sides. The square root of 40 is not perfect, so that means we have a few choices. Depending on what we're doing, it could be reasonable just to leave that as square root of 40 in its radical form. Another option could be to simplify the radical. We can expand out square root of 40 to be 4 times 10. That's important because 4 is a perfect square and we can take the square root of that. So if we want to simplify the radical to leave our answer that way, square root of 4 is 2, 10 is going to stay as it is, so we could say that the length of A is also equivalent to 2 times the square root of 10. If we don't feel comfortable simplifying the radical, we can still use rounding. Here we can see that we're looking for B, so we're going to put B into our Pythagorean theorem. That means that 2 must be A, so we're going to plug that in, so that leaves 15 to be C. So now we can go through and evaluate. When we do that, 2 squared is worth 4. We're looking for B squared, so that still stays there. 15 squared is 225. To solve, I'm going to go ahead and I'm going to subtract 4 from each side. So when I do, that tells me B squared is worth 221. So to get down to just B, we need to take the square root of both sides. Now 221 isn't a perfect square, and I'm not sure I'm going to do a good job of simplifying that, so I'm going to go ahead and estimate. When we estimate that square root on a calculator, we get 4.86, yada, 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 yada. So from there, we're going to do some rounding. We're going to go ahead and round off to the nearest tenth. That 6 is going to tell the 8 to bump up, so that means we're going to round 14.866 off to about 14.9 and leave that as our final answer. Check out the other videos in our playlist and don't forget to click on subscribe. Thanks for watching!